Morning, everyone. So, April 1st, 8, 8, 8 1. So, we start with just we will revision what we have completed. So, what is Snowflake and why Snowflake? What is workflow? For the second. So, we will revision everything what we have completed. Then we will move into the subject. See, SQL. So, here, SQL, see, here, Snowflake. See, so we have data in Oracle, some tables and some code, okay, procedures are UDF. So we need to move that into the Snowflake. Okay, we need to move that into the Snowflake. Okay, so that is we can call it like data. So migration means so we have data in some in OLTP systems and we are moving that data into OLTP system, OLAP systems. Okay, we have data in OLTP systems. So we are moving that data into OLAP systems. Okay, your workflow is like okay, Oracle to S3. Okay, or like ADF or blob storage. Okay, then again GCP, Google Cloud Space. Okay, GCS we can call. Okay, GCS. Then after coming to data, when we have data in these cloud providers, so these data we need to move into the Snowflake. Okay, and after moving data into the Snowflake, we need to connect with the dbt. Then we need to do the transformation, and then again we need to connect with the Power BI or Tableau. Okay, tab. So this is the completely workflow. So for in between or data processing for scheduling, okay. So we can use the dbt cloud scheduler or Airflow, Fivetran. There are other different tools, okay, like SpyPark Python for data processing. But so this is enough to complete doing the data migration project. Okay, these are skills. Okay, so Oracle to S3, S3 to Snowflake, Snowflake to dbt, dbt to Power BI. So this is the complete workflow. Here the ETL team going to push the data. Okay, so who going to push the data? Oracle to S3 bucket. There is like ETL team. Okay, push the data Oracle to S3. S3. Okay, so ETL means like extract and transform and then load. So it will going to do. So using Informatica, okay, Informatica or like ADF, they're going to push the data. So ETL. So when we have data in S3 bucket, so as a Snowflake developer, so our process will be start. So we need to load this data into Snowflake data warehouse. Okay. So Oracle is OLTP and Snowflake is OLAP. Okay. OLTP means like online transaction process. OLAP means online electrical process. Okay. So Oracle SQL Server, those are OLTP like so for daily day-to-day activities like so we are going to bank, we are withdrawing and we are depositing money, right? So everything in done this day-to-day activities in the OLTP systems. But OLAP is for I need output. Okay, I need to share output after 1 month, 2 months, and 3 months. That is OLAP systems like the reporting. Okay, I need sales summary, total doctor visits. So not immediately. I need after 1 month those details. Okay, records. So that is OLAP. So this is OLAP is Oracle. OLAP is OLTP is Oracle. OLAP is Snowflake. Okay. So in interview class, what is the difference between OLTP and OLAP means? So OLTP like for the day-to-day activities, transactions. OLAP for LT for the data processing unit explain. Okay. So here, so this is okay, why Snowflake? Why we are in Snowflake means like it is having multi-cluster warehouse and separate storage, separate layers, and Snowflake architecture, separate layers like a database storage layer and compute layer and cloud services layer. We have separate layers here, separate layers. This is one point. And SaaS model, no need to install anything. Just we can create online account. We can start using and pay as used. It means if you're going to book Rapido, like Ola, Uber, right? So you're going to travel some distance, one place to another place, like 5 to 10 kilometers. So you are not buying that bike and you are not hiring that person, Rapido driver. So just you are paying for that distance. So for that, you are paying for the distance only. So like that here, okay, pay as use model. So what you use, you need to pay for. So that only. So suppose I have 2 TB data in Snowflake, 1 TB is active, okay, and 1 TB is not active. Okay, here we need to pay for only this 1 TB is active, right? So this, okay, 1 TB we need to pay like $23 per 1 TB. Okay, and storage is cheap. Okay, cheap in the Snowflake. Okay, we have compute cost, but storage is cheap. So this is pay as use model and the scalability. Scalability means like whenever we are running the queries and data loading, okay, and SQL query, okay, when it's slow, when slow, so within a second we can increase the warehouse size. That is like a scalability. So if you go with other warehouse like Redshift or BigQuery, it will take some time, maybe hours or 2 days, like 1 day. But here within a second, we can increase the so warehouse size. That is advantage in the Snowflake. Okay. The pay as is model. So separate layers we have and scalability and multi-cluster warehouse. Multi-cluster warehouse. And so we don't have the indexes in the Snowflake. Instead of indexes, we have micro partitions and cluster key. Okay, this is first go with what are the additions in the Snowflake. Addition in the Snowflake. Okay, so by default, when you create in the Snowflake account, okay, you can see only three editions like standard and enterprise. Okay, then you're going to see business critical, and then you're going to see these are three editions. You can see here it's going to be like $1 for 1 hour, and so $2 for 1 hour, and here for business critical $3. So, because of in real time we don't use standard, it is having the only basic features, and we're going to work with enterprise edition. Okay, enterprise edition. Okay, suppose you are having like bank projects. 1 second. So here we have three editions: standard $1, enterprise $2, and business critical $3. These are when we are creating the account we can see, but in real time we're going to have the four. What is like a virtual private, okay, Snowflake. This is on the discussion. It's going to have like $6 or maybe $5 or $7 for 1 hour. Okay, so standard we don't use in real time. Okay, do not using real time. So for enterprise, for healthcare domain, we're going to use healthcare or retail project. And business critically, we are using for bank domain. The VPS for high priority, like need more security again, comes on bank domain. Okay, so depend. Okay, if you want to get a fourth edition, we need to discuss with the Snowflake team. Okay, that Snowflake company, there is one team. They we going to with Snowflake support. Then they will provide this fourth edition. Okay, here we have only basic. Here we having time travel and everything. So here we more security. Here like enhanced security. If you go higher level, so more cost, more security. Okay, so these are the four editions in the Snowflake. Okay, so Snowflake have three cloud supporters, or we can say providers. So one is like AWS and Azure and GCP. So what is the time of they are using AWS? This is from 2014, and Azure this is 2018, and GCP 2019. They are using as a cloud provider to the Snowflake. Suppose if you create table and we're inserting data, that is going to store in the this AWS cloud. Okay, so next move to first we will create account. So I will explain step by step. Just go to here, type Snowflake account creation. So here you can see Snowflake trial. Wait for a few seconds. So give first name, I'm giving time, variant. I'm giving my personal mail ID. Okay, I'm a student, or you can choose training for certification for my job and continue and give company. I'm giving the IBM and job title. So data engineering. By default we are going with enterprise edition. Okay, we have standard enterprise business critical VPS. For fourth edition, we need to request the Snowflake team. So go with enterprise and choose cloud provider. So AWS, and we have different regions. Okay, so across regions we can share the data also. So I'm choosing Singapore. So check mark. Previously also have the India Mumbai. So now we don't have. So it's when it's updated again we're going to have the India Mumbai. So now it's removed from this region. Again we're going to have no worries. Okay, choose Singapore. So I have read, get started, skip, choose SQL and submit. Just wait for a few seconds, setting up your account. So go with here Gmail. You're going to receive one activation link. Open this activation link. Click to activate. Username I am giving like April 1st. Okay, April 1st, 2026. So this is I am giving username. Password it should be like 14 characters minimum. we save and make a bookmark. So this is interface. Go to here, plus button, select SQL file. Okay. So again, plus button, SQL file. Okay. Here you can see this is a snow site. Previously we have Snowflake web UI. Okay. What are the Snowflake web UI? Here we have classic console. So this is a old one, good for SQL queries. Good for SQL queries. Okay. And this is disabled for trial account. For trial account, 2023 July. So July, okay, only for trial account. So, but in real time we can get it. Right, a new one, snow site. Okay, so this is a snow site. This is the snow site. Okay, where we are working, and this is new one. So present, we going to use present. We going to use. Okay, and third one like snow SQL command line. So that we need to install and we need to connect with the, we need to open command prompt and we need to log in with username and password. That we will also do. So using command prompt, that is SnowSQL command line. So what we are doing the Snowflake, everything we will do in the SnowSQL command line. So but when we use or in real time, so far when we have data in on premises in our local machine in our computer system, then we will install and we will load the data. Okay, this is SnowSQL command line. So this is the interface. Okay, these are the account admin is the first person. Okay, we can access everything in the Snowflake account. Then we have organized admin, public sector admin, system admin, user admin. So everything there is RBAC policy, role based access control. Okay, so we will discuss in the next classes what is these roles and everything. Okay, so first we need to have the warehouse. What is the hierarchy here? So warehouse, then we need a database and a schema and table. Okay. So there is no relation between having relation between database schema table, but there is no relation between warehouse and database. Okay. For this database, you can use any warehouse. Okay. Warehouse is like engine. Okay. It have power like bike and car having engine like that, and it's going to do the compute processing. So running queries, okay, large queries, small queries, everything, okay, every transformation done by the warehouse. Is it like engine? It going to the process. Suppose I'm running the select star from table name where ID equal to 2 lakhs. So it going to run in this warehouse. We can choose compute warehouse or system streamlit notebook for Python AML work. They're going to use this notebook streamlit work. So presently, we can, this is by default, we have compute warehouse, but in real time, so we're going to create our warehouse. Okay? We need to define the price and everything. So that also we do. We're going to create warehouse also in the, with options. We're going to create warehouse and with this typing with the text also we're going to create. So creating warehouse with the text is good. Okay, and options also we can create selecting options, but creating a warehouse with the text is very good. Okay, it's going to be strong. We can mention everything. Okay, so there is no suppose I'm creating one database. Okay, I'm using compute warehouse. The query is running slow. I can move to another warehouse, then I can run the query. Okay, that's why everybody thinks there is some I am using warehouse, I am creating database one, so I need to use this database only in this warehouse, not like that. Okay, so you can use this. If you create a database one, you can use any warehouse, like warehouse 1 you can use, warehouse 2 you can use. Okay, for the there is no relationship, only have the relationship database, schema, tables, these things. So for a one database you can use any warehouse as per your requirement. Data loading, if the query is slow, so you're going to change the warehouse or increase the warehouse size. Okay, so this is about warehouse. Then go with choose database. So here we have like Snowflake. Okay, and Snowflake sample data. Okay, user April 1st, 2020. By default, we have these databases. Okay, you can see. So you can choose from here, and you can see and explore. Okay, not coming. These are okay. By default, we have these the Snowflake and Snowflake sample data. So I'm just already small query select start from. Okay, I'll go to this sample data. So why many people are using Snowflake means, see, we have 8 tables. So in customer table we have, see, 150 crores records. See here you can see 150 crores records we have. So 10.1 GB. And in this table we have some other, okay, 159 GB. Okay, nation. Okay, these are, so we go with customer. So 150 crores records, place name editor, it going to give the fully qualified name here. Okay, so this is database name. This is only sample data. If you want to practice, you can go with this sample data. So but in our training we're going to take our own data, completely healthcare domain. We're going to take, okay, some tables like 26 tables, and we're going to work with them completely, creating raw layer, okay, staging layer, curator layer, and dev environment, test environment, and production environment. Okay, so this is database fully qualified name. So always go with fully qualified name. So don't use select star from table name. Okay, always go with fully qualified. Why? Because of, so in real time, so every time we're going to mention only fully qualified name, so not directly table name. Okay, so this is database name, and tpch underscore s 1000 the schema name. This is the table name. Okay, so if I run the query, so we have 150 crores records, right? Okay, so it will take some time. Okay, so for that, what I do, I'm canceling this query. Okay, and I'm using limit, and I'm giving uh, B45, 10 lakhs records. I'm fetching 10 lakhs records. So let's check how much time it's going to take for 10 lakhs records. So it is taking only 4.4 seconds for 10 lakhs records. Okay. So this is our advantage. Okay. These things we cannot handle in the OLTP systems. Okay. So that's why Snowflake is like a warehouse, right? A warehouse handling the large volumes of data, data processing, and everything. Okay, so see these things. Okay, data. Okay, but we going to work with our data. So we have so multiple tables and healthcare domains. Okay, and healthcare domain, and I will provide also bank data and those things. So these data, okay, our data is this one, and tax package like medicine data. Okay, we also going to have the so not 10 records or 20 records we have here. So more than 2 lakhs records we have. Okay, more than 2 lakhs records we have. Okay, 2 lakhs records. And some other table. Okay, so see, enhance these data having many columns. Okay, this is some. So this is some data, but having more than 150 columns. 150 columns in a single table. Okay, so we're going to handle these data also. So more than 150 columns, I think so. Okay, so why this data means we're going to get a real-time experience. Okay, if you take 10, 20 records, just you're going to learn the concept. But if you take the large values with the 150 columns, you're going to get the real-time work experience. Okay, this thing. So now what you do, what you going to do? Just uh, we going to create our own database. Okay? how to create a database. Okay, create everyone like this only. I will give today one task. Create. We can use create or replace a database. Okay, database name. Okay, I'm giving dev. Okay, help. Okay, db dev help healthcare. Okay, dev healthcare db. db means database. Control enter we can use, or you can use play button, run button. So see here, we will to minimize these things. So refresh. Okay, so this created healthcare table, right? Okay, open this up. So when we created the database, this is one interview question. Okay, when you created the database, so by default it's going to create information schema and a public schema. Remember, so when you create the database, by default it's going to create information schema and public schema. Okay, so now I'm going to create a schema. Okay, by default it will create information schema, public schema. We can use those schemas, but now in our training we're going to create our own schemas, or you can use those. Okay, again we can use. So again, so create or replace, so schema. Okay, help healthcare scheme. Okay, again I'm using control enter, or you can use run button. Okay, so schema is created. So now see refreshing. So now we have, see, right, dev healthcare schema. So place name, enter, copy name, editor definition. Okay, yeah, we have different things. Okay, so how to choose? By default, or when we are creating, so it's going to select by in this place dev healthcare db. Okay, now we don't have here list, right? Okay, just refresh this web page. Okay, now click on here. So you're going to have the dev healthcare db. These are sample databases. Okay, if you want to change anything, go to here snowflake and choose account usage. Okay, by default it's going to select by this place, snowflake account usage, or go with. Okay, and this dev healthcare db and dev healthcare C. Okay, choose this one. So now what we are doing means, okay, now we have database dev healthcare db. Now we have dev healthcare schema. Okay, now I'm going to load one table. So there are two ways I will show you how to load table. So we have first I'm not creating any table, I'm loading without creating the table. Okay, so so expand this. Here you can see ingestion, add data, load data to table. So browse. Okay, go to desktop. Okay, all, go to snowflake. Okay, I'm choosing us healthcare data. I'm choosing a drugs package. This is 26 MB. We need to choose the database. Okay, dev healthcare db and dev healthcare schema. Okay, so create new table. Okay, so if already table is created, we can choose from this button. Okay, choose from this button, but we don't have the table, right? So give any name, drugs package. Okay, we can give medicine data. We can give, okay, drugs package data. Okay, so give it in by default it's going to take, or if already table is created in the snowflake, it's going to show from this drop button, but we have not created, that's why we are giving the name. So by default snowflake going to create this table, drugs package data. Click on next. Okay, so I will explain after this. After click on this low. So successfully loaded data. So you can click anything, view table details. There you can find it. And here click this home button, left side corner top you can see home button. Click. So this is your top newest worksheet. Okay. So now I am selected. Select start from refresh. So we can write the table name, but I'm not typing it. I'm selected from this because of I need fully qualified name. Click place name enter. Okay. So this is the table. Okay. So this is the data. Okay. And one second. Okay. This is without a fully qualified name. Okay. And this is with the fully qualified. Okay. This is with full qualified name. So without fully qualified, but use always this only. The database starts schema dot table. Okay, this is one way to create the loading the data. So direct without creating the table, by default it's taken text package data. So even it's taken like okay these data, okay, product ID, product NDC, NDC package code, package description. Yeah, if you want to see the table definition, okay, select get the DLF. This is must we need to know what is a table name. We need to paste it and we can choose the table. So by default, it is created the table like this. Okay, copy this code. We have not created. So usually we need to create the table. So see, create our reference table, text package data, product ID, product NDC, entities package code, and package description. Okay, data type is taken for every value only varchar. Why? Because of even in ID also we have the string values. String values we have, right? See, a BD, CBE, and BD we have product indices we have hyphen. So we have string values varchar alphabetical. Okay. So we have string values. That's why it's taken varchar for even for product IDs. If you give number, it's going to throw the error. So this is by default. So now what we're going to do? So we need to do for today for every file. So here this file. Okay, just what I'm doing, just do it same process. Okay, first I have tracks product, right? Just I'm copying this file name. Okay, so go to here. Okay, see, paste here the comments hyphen hyphen paste. So copy, sorry name, and copy the name and go to here, paste. Okay, that's product. And now what you do, open this one. Okay, so copy this one, copy the so columns. How many so paste. Okay, again give the comments. Okay, so these are the columns we have in that file. These are the columns we have. Okay, so next step what you're going to do. Okay, so here go to chat gpt. So because of creating table it will take time, right? So no need to every time typing. Okay, there is no need to type every time. Just go to chat gpt and if you time it will take okay 15 minutes. Okay, don't do not waste your time. Okay, for just what you do, uh, take, see, go to again this file. open this. Okay, copy fewer rows. Okay, okay. Here, go to here, copy fewer rows. Okay, and go to here, paste the data. Okay, so now how you going to get the prompt? Okay, and go to here, and this is the text package, right? So for every, this is the file name. Now go to here, create table text product underscore data. Okay, check above four columns and data improper data type. Okay, create table for Snowflake warehouse. Okay, for Snowflake warehouse. So then it going to create the table. See, so now it go to copy this one. Now go to before. Okay. So create or replace drugs product data. Control enter. Table is created. Okay. We can check the data. Okay. Select start from. Okay. So go to refresh here. Okay. So this is a drugs product data. Go to here. Okay. Then check. So now we don't have any data. Okay. So we have so this. So we don't have any data. So we have subcolumns. So now how you load data? Okay. Or just rejoin with the same link. We'll continue the class. Okay. So now okay, there is only 1 minute. Rejoin now with same link. Okay. Rejoin with the same link. I'm ending the meeting. Rejoin with the same link. Okay. Remember one thing when you go with creating table field, we have many columns. Okay, you have large data. Okay, many records. Don't type. Just use ChatGPT. Okay, to save your time. But for syntax, deleting duplicate values, writing queries. Okay, and so for updates, do not use ChatGPT. Only for the creating table to save the time for the time concern only, not for this deleting duplicate values and changing the tables and data loading, data unloading. Do not use those tools. Okay, to save the time concerns, use for those things. Okay, so now what we do, go again, we need to load this data, right? Okay, so here you can see add data and load data into table. To browse, and I'm choosing drugs product. I'm choosing database table health db and the table health schema, and then create new table. Click, you can see drugs product data. So we created. So I'm not typing here. Just I'm choosing from this drop down button. You can see drugs product data. Choose it and go to next. Okay. Wait, it's loading. We have 36.9 MB. Okay, symbol. Okay. So choose here file format. It is a CSV. So the Snowflake going to support JSON, okay, Parquet, Avaro, JSON, Parquet, Avaro, ORC, XML. So now we have delimited file CSV. Okay. Then we have options header, first line contents header, no header, skip first line custom. So because of in data, so they already are. So this is the header, right? Product type, product NDC, product name. Okay, already we created table with column names. So okay, what we no need to load those data again, right? So that's why we need to skip the first line. It's going to skip the first line and it's going to load from the next part. Okay, and So we have some errors, no worries, we will fix it. Okay. And the field delimiter, comma. So in data, so we have right product ID, comma, and here comma, okay, comma. So this is the field delimiter. Okay, in real time you may be going to have tab, semicolon, space, vertical bar, custom. So most of the time we're going to have the comma, so fix with comma by default. So trim space, okay, if any this one, trim space true or false here in data. Suppose if I have space, the like this is right, if I have space. So this is unnecessary space, right? So Snowflake, what it's going to do, if you use trim equal to or true, it's going to remove the unnecessary spaces. Okay, and the field option includes by single quotes or double quotes. Here, see. So in data, sometimes it's going to receive like here. So here, right? Now here, like I'm giving here the one and one. Okay, single quotation. Sometimes you're going to have the double quotes. If you have like this single quotes and double quotes, so it's going to throw the error. And this is also interview question. So when we CSV files having the double quotes, how are you going to handle the data? How are you going to load that data? So in the time, what we need to know. So here we need to give the this by default double quotes. So this is file format from these direct options, but so usually we need to create the file format that I will create. I will show you when we are loading the data. Okay. So this is by default through the options, but we need to create the create file format name, header, field, trim space, everything we need to mention. But this is from the options from the when we are loading data from local machine to Snowflake. Okay. So but in real time we need to type everything. So field enclosed by equal to double quotes equal true, like that we need to type. Okay. Choose double quotes, replace invalid characters. If we have any unnecessary characters, it's going to replace. And date format, we have right a date. See, now here in our computer, first we have a day and a month and then year. Day, month, year, like that. We will be having like a year, month, date. Okay, like date, month, year. So you can see date, month, year. Here we have 17 December DEC 1980. Here 28/04/2013. Okay, 4/28. Okay, this is the date format we can choose. And here also time format, we have different time zones, right? And different time formats. Okay, it's going to be hours, 24 hours, milliseconds, seconds, something. Okay, something the time format we have. Okay, one second chart. Okay, so time format. Okay, and again this is hours. Okay, minutes and seconds. Okay, like this. Choose the time format and timestamp format. Okay. Okay, here, okay. So date format only date, time format only time, but timestamp format means having date and time. Date and time, okay. Date and time is the timestamp format. Remember, you're going to know. Okay. So this one. Then this is. So this will append default. Okay. So data will be appended to the exciting table with the copy into. It means if already this table having data, that's for data, so it won't delete that one. Okay. So it's going to append the data and it will load to data. Okay. And means suppose we already have so 1 lakh records in this tax product table. So what it will do, Snowflake, uh, next 1 lakh one from that point, it's going to load the data. It's not going to disturb that 1 lakh records. That is append and replace. All exiting tables rows will be removed with the truncate and files will be loaded with the copy into. It means so I don't want that 100 or that 1 lakh records. It's going to truncate the table, truncate table name. It will truncate table and it will load only this new data. It going the data going to go going to truncate. It going to truncate those 1 lakh records, and it will remove that records and it will load the new data. That is this replace. We go with append. So what should happen if an error is encountered? Here you can see, do not load any data. Suppose do not load any data, default on a equal abort statement. Suppose if you have any error in the data, it's going to give the abort statement. It will stop the running that statement. It will going to stop the running that statement. Okay. Next, only load valid data from the file on a equal to continue. So only load valid data from the file and we could continue. Suppose if you have 2 lakhs records and the 1,50,000 records are good records and 50,000 records having some errors. So now what Snowflake will do? So here we given honor equal continue. It will load this good data 1,50,000 records into the table, and it will skip those 50,000 records. So in that time, we need to load good data into one table, and remaining that 50,000 records we need to load into the error table. We need to get error table, and we need to load in that error table. Okay. So this option. Okay, only load valid data from the file and are equal to continue. So load, I think we do not get any issues, but here we have a red mark. Let's check. So here of failure to load data. So error line 13, character 27. So columns having the active numerator strength. Numeric value is 3 to it is not recognized back. It means data type issue here. Okay. Here it is giving the numeric value 3 and 25 is not recognized, but it is given different data type. So what we do here, go to home, click on home, go to here. So we have some issues, right, with the data type. So what we do, so now I'm going to give, okay, here string, okay, here it's going to throw again data. I'm giving again for this for varchar, or you can give string also. I'm changing, okay, string, and in the mark of fund date I'm giving the only string. If I give date, it's going to throw that because we have many records, right? And again here float, I'm giving string and string. Okay. So previously this table also taken for everything varchar, right? By default, okay, like that. Okay, we need to take. So string and varchar both are same. Okay, don't confuse. String and varchar both are same. Okay, so varchar is string. Okay, string. So here instead of string we can give varchar both. Okay, now everything is string. Now control enter. So it will recreate the table. Okay, so now again go to plus this data. So choose. So I'm going to just choose DUX product. Okay, choose database, choose schema, then DUX product data, then next already okay. So again, no need to change. Okay, by default it will handle by the Snowflake. No need to just directly click on the load. So we have table details. Okay. Go to home button. Okay, and data. Now data is loaded. So now what you do? Now run this 15th line. Okay. So this is okay. How to load data. Okay. So this thing. Okay. So totally 1,17,365, and here we have like uh, many columns like okay, and many columns. This is how to load data. Local machine to Snowflake on premises. Okay. So everything that file format. Okay, we're going to create. No worries. Okay. When we move into the subject. Okay. So this is data loading, and now just I will explain recap about micro partitions. Yesterday we have seen about micro partitions, right? Okay, so how the data going to store in this Snowflake means in this format. Okay, so when they ask about how the data going to store, so the data going to store like this. Okay, this is the logical structure like table. So in table we have four columns and a physical structure. In the inside the Snowflake, and we have 24. So 1 to 6 partition 1, partition 2, partition 3, partition. Why this partition means? Suppose if I run the query without the partitions, if I run the query, it's going to scan entire the table. But you have I have divided into 6, 6, 6, 6, right? Totally four partitions. When I run the query, where where ID equal to, okay, where date equal to, okay, 11 by 5. So now it's going to scan. Here we have in the only fourth partition, so not every partition. Okay, to save the time and to save the cost, we have the micro partitions. So in Snowflake, it won't support for the indexes. Instead of indexes, we have the micro partitions and cluster key. Okay, so when we going to apply cluster key, so when we have the large data, so and we are using one column like repeatedly many times. Okay, again and again we are running, we are using same this country column we are using in everywhere in the queries. So we're going to apply that cluster key on this country column. So not data should be like billions of records, not okay. Like 10 records, 100 records, or 1 lakh record, 2 lakhs record. It be so 10 millions, okay, 1 million, okay, billion. So records we need to have the records. In that time we need to apply. Okay, so when you have the larger data and we are using that, okay, column repeatedly, then we need to apply the cluster key. So you can apply on every column cluster key. There is no limit, but real time we need to apply only one column, two column, three column, maximum only up to three columns. If I apply more than three columns, it is going to, okay, take the more cost and there is no use. So only the magic into they will ask how many cluster keys we can apply on the table means. So we can apply, there is no limit for cluster key. We can apply many, but in real time we going to apply only up to three. If you apply more than three cluster keys, it's not going to use, but we need to pay for that. Okay, apply only one, two, three, and Snowflake knows when we are loading the data. Snowflake knows like metadata like row count, null count, what is the min value, what is the maximum value. Snowflake knows. Okay. Now I'm loading the data. The maximum value is the 1 lakh. Okay. So after some time I'm loading the some other data. The maximum in the data, the maximum value is the 1,70,000. 1,70,000. Okay, it going to replace that maximal with the 1,70,000. So Snowflake knows like row count, okay, minimum values, maximum values, how they're going to store distinct values. Okay, so this is advantage of Snowflake. When we fetching the maximum select star for maximum salary from table name, it not going to scan the table directly, it gives the output. Okay, so this is, okay, Snowflake. Okay, when we run the query. Okay, and we have query pruning. Okay, query pruning. Okay, I have explained in the last class, I think so. I have not explained query. What is the query pruning? Simple. So whenever we run the query, the Snowflake not going to scan the every partition. Okay, it will skip the irrelevant partitions and it going to scan the only relevant partitions. ఇట్ మీన్స్ ఏంటంటే మన క్వరీ రన్ చేసినప్పుడు ఏదైతే డేటా ఉంటుందో దానికి అయిన అవసరమైన డేటాని మాత్రం స్కాన్ చేస్తుంది. ఏ డేటా అయితే అవసరం లేదో ఆ డేటాని స్కిప్ చేస్తుంది. Simple. Snowflake going to skip irrelevant data and it will scan only relevant data. Irrelevant, relevant. It will skip irrelevant data. It will scan only relevant data. So what it needs, it will scan only that data. That is the query pruning in the Snowflake. Okay. So cluster key, we can apply. Okay. Cluster depth. Okay. So this is we discussed micro partition. Then Snowflake architecture. See, Snowflake architecture diagram. Okay, go with this thing and go with our documentation. Okay, so what I'm explaining in the class, so go with only those definitions. Okay, do not get for somewhere else. Okay, what I'm explaining, go with only those. do not search for definitions in the chart gpt. Okay, and in google, okay, it will give proper, google with the proper, but so what I'm explaining, because of, so there is definition maybe in different way, but if you work real time you're going to get one idea, right? So that idea I will give. If you work real time you're going to get one idea about definition. So you're going to get one idea. So in Google having some definition, that is good, ChatGPT good, Google having good. But so when you work the real time, you're going to get one some idea about definition about any topic, okay, any like feature in the Snowflake. So follow that definition. So what I'm explaining in the class, so follow only that definition. I will provide the notes also. But when I give in the class, right, observe my words and follow that definition only. You can note down in the notebook while class running. Okay, that is good to you. So this is a Snowflake architecture. We have three layers. Okay, so database story layer, compute layer, cloud services layer. Here, Snowflake going to support structure. Structure means like CSV files, semi-structure like JSON files, unstructured like audio, video files, images. But directly we can't load into the Snowflake this unstructured data. So when we have these files in S3, we can access the metadata in the cloud provider S3, Azure, GCP, in S3 bucket. That is a data lake, right? When you have the data in the data lake, in S3 bucket, we can handle the metadata. So, but we can load these structure and semi-structure CSV files and JSON. We are going to handle every data, okay, here. And here, database story layer, compute layer, and cloud service layer. Okay, when we create the table, the data going to insert, we are inserting it. We create the table and we insert data, right? That going to store in this database storage layer. And this is a compute layer, okay, having the virtual warehouse, like this is the warehouse. So we have seen, right, this is the warehouse. Virtual warehouse means, so these are the so compute warehouse, systems unit warehouse, these are the virtual warehouses. Okay, so each virtual warehouse is independent. Okay, each virtual warehouse is independent. For a dev environment, we're going to create one warehouse. For a test, we're going to create one more warehouse. And production, we're going to give one more warehouse. Okay, different warehouse we're going to create for the, as per the requirement. Okay, it was going to create with the admin. So that knowledge also I'm giving. What admin can do, you can do also. Okay, this is compute layer. It means suppose I'm running the query select star from table name where id equal to 7 lakhs. So the query going to run in this layer. Okay, and suppose I'm loading the data, I'm doing the transformation, delete the duplicate values, inserting the data, updating the data, delete data. Okay, I'm applying window functions, rank, dense rank, everything done in this compute layer. So the data we have in the database story layer, and this is compute layer. It's going to run the data. Okay, it's going to do the processing the data. Okay, this one. Okay, storage here, running the queries in the compute layer. Okay, simple. What is a virtual warehouse? It is set of multiple computers, like having the nodes, and multiple computers having the RAM, SSD memory, CPU. Okay, whereas in a set of multiple computers, it's like an engine. Okay, and we have cluster keys. Okay, clusters. Okay, cluster keys in the tables, it's going to have the clusters and cluster keys different. Okay, clusters. So that I will explain. Okay, tomorrow we're going to create the warehouse, right? In that see, we're going to see about clusters. And this is cloud services layer, and going to secure. Suppose if we want to log into Snowflake account, we need to have the username and password, right? So that will take care of this cloud services layer. So management completely, we know we are not installing anything. Just we are loading the data, we are doing the process. Everything managed by the Snowflake only. Even it won't support the indexes. Instead of indexes, we have micro partitions and cluster key. It will by default. We have micro-partition cluster key. It will handle by the only Snowflake. We are not creating the micro-partition. Okay, just we are loading the data. So by default, Snowflake won't handle those data. And you have metadata. So like every table have going to have the metadata. These things will be handled by the cloud service layer, and optimization like query optimizations, those things. Okay, completely security. Suppose I want to connect with the dbt, then comes to the cloud services layer, and I want to connect with the Python, come to the cloud services layer. Okay, and I need to connect to the Power BI Tableau, come to the cloud services layer. Okay, this connection and security going to provide. Okay, so here data will be stored, here query will be run, it's going to take care of the security. And one thing, these are separate layers. When we have 10 TB data in the 20 TB data in the database store layer, I am running the query. So this query won't affected by this storage 20 TB data. So I'm running the query, I'm loading the data, okay, and I'm transferring the data, okay, I'm unloading the data, loading the data, and it won't affect by these 20 TB data. Okay, 20 TB is an example. So this is separate layers. Okay, separate layers, separate. So that's why every client going you are using these Snowflake, because we have separate layers. It won't. We will get a quick result. Okay, quick result and fast process. So to save the we can save the time and we can save the cost of as well. Yes, so that's why every client and everyone they are using the it's Snowflake. Okay, so these are three layers. Okay, remember, database to layer, compute layers to cloud services layer. So in interview when they ask about Snowflake architecture, you need to explain about these things. How the data will be stored in the Snowflake micro partitions. How you work with the indexes, tell about micro partition and cluster key. Okay. And one more thing, if they ask about Snowflake project architecture, that is different. We need to tell about layers or environments that I will explain in the next classes. Okay. So this is about this we have completed from here, so I have revised everything. Okay, so tomorrow we go with warehouse creation. Okay, so see, warehouse creation. Okay, as of now, anybody having a doubt or regarding this section? And okay, if you have any doubt, ping me in the WhatsApp. Okay, in the WhatsApp if you have any doubt. Okay, no worries. If you have any doubt, I will connect with you. Okay, I will connect with you, I will explain. So thank you, thank you, thank you. Have a great day. Bye.